Today we're going to be looking at Section 11.6, Further Graphing of Quadratic Functions. On example 1, we have the quadratic function f of x equals x squared minus 4x minus 12. It asks us to find the vertex and any intercepts. So it's pretty nice because x squared minus 4x minus 12 factors into x plus 2 times x minus 6. So the intercepts are negative 2, 0, and 6, 0 because we let x plus 2 equal 0, and when we do, we get a negative 2. And when we let x minus 6 equal 0, we get a positive 6. We know x-intercepts, the y, is always 0. So we have our x-intercepts then at negative 2, 0, and 6, 0. The vertex is halfway between these, so the x value for the vertex is simply a negative 2 plus 6 divided by 2, and we find that the vertex x value is 2. Plugging in x equals 2 into the original equation, we find that 2 squared minus 4 times 2 minus 12 is a negative 16. So the vertex is at the point 2, negative 16, and this is one way to find it. Yet another way is using the vertex formula, and we can do a negative b divided by 2a and find the x value of the vertex. Then we evaluate the function at that value minus b divided by 2a. So they ask us to find the vertex again of x squared minus 4x minus 12. Plugging in a negative 4 and 1, we find that it is minus a negative 4, which we know is 4, divided by 2, which is just 2. So our x value of the vertex is 2. Plugging that in the function, f at 2 equals a negative 16. So once again, we find that our vertex is 2, negative 16. Now they're asking us to graph our function x squared minus 4x minus 12. Well, we know the intercepts. Here's one of them, negative 2, 0. The other one is here at 6, 0. Those are our x-intercepts. And the vertex is simply at 2, negative 6, which if we come down here, we have 2, negative 6 right here. And then we draw our x squared function. Taking it through our intercepts, and there's the graph of our function. Find the vertex and any intercepts of 3x squared plus 3x plus 1. Well, we go back to our vertex formula of negative b divided by 2a. And plug our numbers in, and we get a negative 3 over 6, which reduces to a negative 1/2. So the x value in our vertex is a negative 1/2. Plugging negative 1/2 in for x into our function, we find that the y value is a negative 1/4. So the vertex then is at negative 1/2, 1/4. Looking for any y-intercepts, we set x equal to 0. So f at 0, we plug that in, that goes to 0, and that goes to 0, and we're left with just 1. So then the y-intercept is at the point 0, 1. Graphing that function 3x squared plus 3 plus 1, well, we know we just solved for the vertex at negative 1/2, 1/4. So we look and we estimate negative 1/2 is about there and positive 1/4 is about there. So we'll put our vertex in, and the y-intercept is at 0, 1, which is right here. And we draw our function as best we can, and we find that our graph looks something like that. The vertex and any intercepts It's what they want us to find of this equation, f at x equals a negative x squared minus 2x plus 3. When I first look at this negative x squared, I know that our graph will be flipped upside down. When you put a negative in front of the x squared value, it flips it over the x-axis. But they ask us to find the vertex and any intercepts, so we'll go ahead and go to our vertex formula and plug our values in from our equation, and we find that the x value is a negative 1. Then we evaluate the function at that negative 1, plugging in negative 1 wherever there's an x. And simplifying, we finally find that the value of y is 4. So the vertex then is negative 1, 4. Setting the equation equal to 0, we find that it factors quite nicely into x plus 3 times x minus 1. So then if we set the first one, x plus 3 equal to 0, we find x equals negative 3. The second part, x minus 1, setting it equal to 0, we find x can be 1. So the intercepts then are at negative 3, 0, and 1, 0. We know on the x-intercepts that the y values are always 0. We also check for the y-intercepts, and to do that, we find the function at the value where x is equal to 0, and when we plug that in, if we look back up here, if we put 0 in, that goes away, and that also goes away, and we're left with just the function f at 0 being 3. So we find the y-intercept to be at 0, 3. On example 4, we're asked to graph the function that we just found the vertex, the x-intercept, and the y-intercept. So we'll begin with the vertex, and it's at negative 1, 4. So I've got negative 1, and I'm going to go up to 4, and I'm going to put a point there. That's my vertex. The x-intercepts are where it crosses the x-axis, so we do negative 3, 0, which is right here. And we'll put a point, and then we have another one at 1, 0, which is right here. And furthermore, we know the y-intercept, and it's at 0, 3, which is right here. So our graph, again, is flipped upside down, so instead of a smiley like we've been looking at, it looks like a frown. And we're going to draw our graph through those points as best we can. And so we have the graph of negative x squared minus 2x plus 3, and indeed, he has flipped upside down. Switching gears, we find the minimum and the maximum. The quadratic that opens upwards, and we refer to it as the smiley, has a minimum value. And the quadratic that opens downward, and we said it was like a frown, has a maximum value. The y value of the vertex is the maximum or minimum value. So let's look at an example of this. On example 5, a rock is thrown upward from the ground. Its height in feet above the ground after t seconds is given by the function f at t equals a negative 16t squared plus 20t. They ask us to find the maximum height of the rock and the number of seconds it took for the rock to reach that maximum height. So we're looking at the vertex, and we go back to our vertex formula, and plugging that in, we get a negative 20 divided by 2 times negative 16, which reduces to 5/8. Evaluating the function at 5/8, we just plug 5/8 into our formula, and after we do the math, we find that f at 5/8 equals 25 over 4. Well, then the vertex is at 5/8 and 25/4. So the x value is 5/8. The y value is 25 divided by 4. We said the y value would be the maximum, so it can be the maximum or the minimum depending on whether it opens upward or downward. In this case, it opens downwards because of this negative outside, so it is a maximum. Then the maximum height is 25/4 feet, which was reached in our x value of 5/8 of a second.